getting ready for our first quiz here in Unit 3. I guess I can move the help sheet out of the way here for a minute. So graph the quadratic, tell the vertex, the axis of symmetry, the min or the max, the domain and range. So there's a lot of stuff going on here. Vertex form, remember, initially looks like this. And my vertex is going to be H and K. The only thing I seem to see people get messed up on with this number is usually okay, because it's just, well, I just copy that, okay. Remember, this H value is the opposite of what you see here. So the opposite of 1 is -1. That's the only one that changes. So, -1, 2. Okay, get my first point in there. Now at this point, I may be able to answer some other questions, but normally I just kind of work my way down. So, and if you want to make a chart or do something and do it a different direction, because I know we've done them sideways sometimes, that's okay. But I always still want to get my vertex in the middle. And in this case, as I'm going down, I would add 1 as I go down, subtract 1 as I go up. Add 1 as I go down, subtract 1 as I go up. Because we've talked before about how these two are the same. Whoops, get my other color here. And these two are the same. So if I were doing these, and they're going to be simple enough, you probably could do the math in your head, even though using a calculator is not a bad thing. So let's say I decide I'm going to plug in 1. 1 plus 1 is 2. 2 squared is 4. Plus 2 is 6. And that gives me the answers to 2 of them. Okay, if I plug in 0, I like plugging in 0. 0 plus 1 is 1. 1 squared is 1 plus 2 is 3. Now, if you're not comfortable, if you're like, no, those little errors he talks about before, I make them all the time. I'd rather either go to a calculator or do something else. You've actually got a couple of other really good options that you could use on something like this. Of course, the calculator is always an option. I could punch it in there. I could pull up the chart. I could punch it in there. I could just do what I just did, except I'm using the calculator, however you want to do it. But, let's darken this up a little bit. So if I go to my y equals, and I go to type this in. Okay. If I did my vertex right, and we've talked about this before, and I get that in the middle, there's my -1, 2, I should see symmetry. I should see the same numbers above and below. And so there's my 3 and my 3. There's my 6 and my 6. Okay? So I'm feeling good that I've got this right now. So we'll get these other guys in. And then I'm going to make mention of one other strategy that we've talked about. We like getting options out there. The other strategy we talked about is the +1 + 3 strategy, where I can start here and I go up 1 and over 1 each way, and then up 3 and over 1 each way, as long as there's not a number in front. I can talk even about what would happen if there was. But that's a third option. So we actually, between all of those, should be able to find something that works for us here. Axis of symmetry always connects with the exact value of our vertex. You've got to remember, okay, you've got to put x equals there. You can't just put -1. If you put -1, that's a number. That's not a line, and it's not right. And it'll be marked as such. Okay, just remember, it's the x value of my vertex, so I put an x with it. Min or a max, it's at the bottom. Bottom is doing the minimum of things. And then domain and range. Okay. Domain is my x values left to right. The one thing we have said about all of these parabolas, okay, all of these quadratics, is this should be the easiest question part. This should be an automatic easy point on every one of these in the front. Because it doesn't matter if it opens up, it opens down, it stretches, it shrinks, doesn't matter. it's always going to be this, because no matter what, it's always going to be opening out to the left and out to the right forever. Now my range is a little different. My y's from bottom to top, there's a couple of ways we've said we can do this as well. I can look at my graph and say, okay, here's the bottom. What's the y value here? Well, it looks like it's at 2. But it goes up forever. Okay. Or I can take the y value of my vertex, and that'll be the point where we start. You can use either one. They'll both get you to the same place. Okay. Now 2 I'm doing to make you think. 2 is also in vertex form. And you're like, wait, what? It is. Yeah. So you look at that and you're like, but there's no parentheses. Here's what it looks like if you're a creature of habit and you want to see another way that it can look. If you don't see parentheses there, all I'm going to do is I can put a 0 into that spot. So if I don't want to write it out that way, if I don't see parentheses, I just know my x value is going to be 0. And then I still get my 3 from that outer part. Either way works. I got my 0 and my 3. And some of you are probably wondering, well, if I can just use the calculator on all this, why would I bother, doing any of these other methods that Harty talks about? And my reason to you would be this. The more you familiarize yourself with doing simple math facts like this, multiplying and adding stuff, the better you get at it and the more confident you're going to be in it. Now, it doesn't mean you can't check with it. But I mean, like here, 1 squared is 1. Times -2 would be -2 plus 3 is 1. Okay, again, in order of operations, I don't multiply and then square it. Exponents come before multiply. So 2 squared is 4. Times -2 is -8. Plus 3 is -5. Now, there's nothing wrong with using the calculator as a double check. Get my vertex in the middle, or at least what I think is my vertex in the middle. There it is. There's my 1 and 1. There's my -5 and -5. All right. So, and again, x and y values. That's the other thing we've been having some issues with. Some of you will see 0, 3, and you'll plot it over here. Okay, you've got to remember, x-axis, how much am I moving left or right? Y value, how much am I moving up or down? Get that in there. My axis, x value of my vertex. Vertex is at the top. At the top, we're at the max of our game here. Domain's my easy part. And then my range. Again, I can look at my picture. But be careful. It's bottom to top. Bottom, in this case, is down forever. This is my top value at 3, or taking it from there. You cannot flip those. You can't say 3 to -infinity. That's top to bottom. That's not what this is. And I'm going to take just a second. I apologize. This glare thing is driving me nuts. So I'm going to try to fix it. There, now I'm not seeing a bluish tint. Okay, that's much better. So, that's what those first couple would look like. So when I get down to 3 and 4, now we're in standard form. Now I've got to calculate my vertex instead of it just being given to me. Now the nice thing, even though this is the quadratic help sheet, there's my little formula for finding my vertex if I forget. Okay, so the backup plan is available. So my A value is 2. My B value is 6 here. So let's see. So opposite of B over 2A. And we've talked before about the need to take your time with this. 2 times 2 is 4. And then all of a sudden, we get ourselves to panic. Negative 6 divided by 4. Harty, it's a decimal. I must have done something wrong. No, you didn't. But wait, if I didn't do something wrong, if that's the x value of my vertex, how am I going to get the rest of my numbers? Because, okay, no, there's no need to panic. Okay, here's why we always have ourselves versed in several ways of doing this. Okay, I got an x value. I'm just going to take it, and I'm going to plug it in. It's my equation. Okay, no big deal. I still got a calculator to help me. Well, that's a decimal too. That's okay. No big deal. You're like, okay, I'm still a little nervous here about this though. So, So does that mean all my numbers in here are going to be decimally too? Yeah, they are. So again, no worries. So if I have negative 1.5 and I add 1, because we do that as we go down, right? Negative 0.5, add another 1 to it. So I have ways of getting the help I need. To go the other way, we always say we're going to minus 1. Okay. Because here's the other thing where some of you get calculator dependent where you're going to have a problem. Because some of you are like, well, why would I bother, again, doing all this? I'm just going to type this into y equals. And I'm going to go about my business and tell Harty he can go on something because I'm just going to use the chart. Oh, but wait, the decimals aren't in there. You're not going to see the symmetry you need. It's not going to be there. So, what we have to do in this case is we have to be flexible. Okay, so I'm going to take this 0.5, I'm going to plug it in. We have to be able to be flexible. I mean, that's just not true in math, that's true in life. We've got to be flexible. So, gets me those two. Okay, I'll do it one more time here with the negative 0.5. Make sure I get this typed in right. So you're seeing here, it's a lot of detail work. Make sure the negative's in there. Make sure I'm plugging it in correctly. Yep. Okay, but I can still get there. So now, I've survived all that. I'm going to go ahead, I'm going to plot these points. And again, it's not probably going to be perfect. So negative 1.5. Okay, so here between negative 1 and negative 2, negative 2.5. Yeah, that's approximately where it is. Okay, negative 0.5, negative 0.5. I've got one here too. And then at 0.5, we're at 5.5. That's quite a jump. Negative 3.5, we're at 5.5. Okay, so I still got there. Axis of symmetry. Still the x value of my vertex. Dot's still at the bottom, so it's still a min. Ooh, new twist. Y-Intercept. You're like, I'm even giving you a hint. The x value is 0. If I stick in 0 here, turns that all into 0. Stick 0 into here, turns that all into 0. It's just your c value. And we talked about that before. Your y-intercept is 0, c, when we're in standard form. So I have that. The domain, has that changed? Nope. Still going to be the same all the way through. My range, same idea as before. I can either look at my graph and go, ooh, that's at negative 2.5, or I can look at my vertex value, and it goes up forever. I'm good. So nothing too bad there either. So the decimal may throw me a little off, but it just means I want you to show me that you're flexible, that you don't get stuck in one way, and that's what you have to do every time. But I won't do that to you a lot. I won't even do that to you in number 4. So we get to number 4. I get my A. I get my B. Again, what's the detail issue here? Remember, it's opposite of B. Opposite of B. Over 2A. 8 divided by 2 is 4. There's the x value of my vertex. There's my axis of symmetry. When I go to get my graph made, I've survived the last one here now. I'm feeling a little better. I've survived it and feeling so good. I'm going to try and avoid using it for a lot of things here. So I'm going to stick my 4 in here. So 4 squared minus 8 times 4 plus 5. Negative 11. You're like, wait. Oh, that does fit on the graph. I was smart. Okay. And again, if you want to go back to the calculator at this point, because you're back, you're like, whew, back to whole numbers. Thank goodness. That's fine. Otherwise, you can just kind of stay on a roll with this. Push yourself a little bit. Try to stretch into an area that you're not necessarily comfortable normally in. Oops, I did this one first. All right. And I can choose either one of these for my other one and get to that value still. But again, I want to notice little things. Like here, my A value is 1, which means it's going to open up. If I start getting numbers and it opens down, I plugged in something wrong. But those are the types of things, again, for those of you that are putting in the time, you're going to notice those things because you've gotten the practice. Get my graph in. Vertex is at the bottom. In. Y-intercept. C value. Domain is the no-brainer. And again, range. You got choices. Take it from your vertex. Take it from your graph. Bottom to top. And again, notice we're just taking our sweet time through here. No rush. Just kind of seeing how all the things work. Again, not bad. You'll probably be faster. Okay, when we get to the back, application. A ball is dropped from the top of a building. The distance in meters above the ground. The ball, after 2 seconds, can be modeled by this equation. Okay? How long will it take for the ball to hit the ground? Do not get sucked into thinking I'm necessarily going to put things in the exact order they are on here. Hit the ground. Ground. I'm looking for a 0. Maybe even you draw a picture and you say, hit the ground is over here. So what do? I'm finding a 0. I'm interested. How long is it going to take to hit the ground? So, clear this out. Get my y equals up. Clear that guy out. Negative 9.8x squared plus 45. Oh dear. Now, this is just a happenstance. I didn't mean to have this happen. Well, what if my graph's all kind of messed up and I can't see what I want to see? Okay. If I hit window. Normally, if people were nice and put it back the way they were supposed to before it goes to the next class, My mins should always be at negative 10, so my y min and my x min should be there. My max should be at positive 10 for both. That should get me something that looks a little more normal, but you can fix that yourself too. So here's what I'm looking for. Here's where we started, some up here. Here's where I'm at. This is what I want to know. When's it hitting the ground? Right here. I have help. Second trace. Try it again. Second trace. There we go. Number 2 is 0. Now I don't see my cursor. Here's what I notice, and this is going to help me out. I notice the intercept's over here around 2. Right now it's at 0. So I'm going to start, after I push this calculator up so you can see me doing it, I'm going to start going to the right, because I'm going to watch for this x value to start getting near 2, because then I should see my cursor guy. There he is. I'm going to get as close to the intercept as possible, as close to the axis as I can. And once I do, left arrow, 1, 2, 3, enter. There's my left boundary. 6 right, 1, 2, 3, high cursor, by cursor, 6. My bounds are set, my intercept is trapped, hit enter one last time. That x value, 2.14, is how long it's going to take for this to hit the ground. So now let's see what the other question is. How high was the building you dropped the ball from? Wait, what? How high was the building? So does that mean I got to do x and then figure out what y is? No. Remember, the value on the end is what our initial height is always. Just take it from the problem. Now, if I went through, here's your saving grace. If you went through and did all this, could you still get to that answer? Mm-hmm. It's a lot more work, but you could. And actually, I'm going to go to the other application and come back to this, so we can kind of stay on a roll here. So this equation gets the height of the ball in feet above the ground in seconds after the ball is thrown upward. After how many seconds after the ball is thrown will it reach its maximum height? Okay, maximum time, maximum height. Height is going to be y. Time is going to be x. I cannot flip them. How do I do this? Follow the yellow sheet. X equals, there's my B, there's my A. Opposite of B, over to A. Do not get careless with your calculator. If you're going to go to the calculator, you do this first, get your answer, then divide. So it's going to reach its maximum height after 1 second. That's not very long. So then the y is just plugging that 1 in wherever the t's are. And if you decide on that one you want to go straight to a calculator, I don't see any issue with that. Again, just make sure you're being careful when you type it in. So it's going to reach a maximum height of 21 feet after 1 second. Done. Okay? But I've got to read carefully, because I could ask you anything on these. I could ask you to find everything. I could just ask you to find initial height. I don't know. I can do whatever I want. So you just have some practice with that. Look this back over. Try it again yourself if you want to. Kind of see how that works. Now this last one is kind of a layup. I'm even going to be nice enough to leave this little hint on here when you're doing these. Okay, for each function, find the y-intercept. 2 ways I can do it. One way I can do it plug the 0 in for x. Now here's the one thing I will stress. Okay, Y-intercept is a coordinate point. Okay? Your answer needs to look as such. If you write y equals 7, that's a line. Okay? That is not an intercept. You've got to put it as a coordinate. You've got to do it. Okay? So on intercept form, I've got to do it that way. Let's say you're like, no, I don't even feel like putting that much work in, Harty. Okay, here's the other thing you could do. See, there's so many options with these if you just play with them a bit. If I look at my chart, because I already told you x equals 0, right? Go down to where x equals 0. What's the y value? 7. Okay, that works too. Either one's fine. In standard form, now I'm hoping you remember the trick with this one, but if you don't, you'll remember it fairly quickly. Zero. Oh yeah, it's just the C value when it's in standard form. Yeah. 0, 9. Okay. This is it. I'm not going to throw any fancy, cutesy things in there. It won't show up in like 20 questions tomorrow. It's this. So, again, extra credit sheet's still available if you want to do that, getting the practice with the homework. Plus that, you're going to ace it plus get extra credit. So some of you, this is a huge way to get a nice little boost to your grade here at the start of second quarter. But that's about it for now.